This PowerPoint slide presentation is going to be on volatile solids reduction percent water treatment math problems. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and correct answers to the questions. This is a study guide. Hopefully it helps you. The formula for volatile solids reduction percent is in minus out divided by in minus in times out times 100%. This formula is off the state of Florida formula sheet they give you when you take an exam. As always, I suggest if your state provides you with a formula sheet that you get it and get familiar with it while practicing this, so when it comes time to take your exam, you know where to find things. Calculate the percent volatile solids reduction if the digester influent sludge has a VS content of 58.4% by weight and the digester effluent sludge has a VS content of 38.0% by weight. As with all word problems, I like to pull out my known and my unknowns. So what you know is you have an influent of 58.4% and an effluent of 38.0%. What we're looking for is VS reduction. So that's going to be the formula we need to use. Again, volatile solids reduction percent is equal to in minus out divided by in minus in times out times 100%. Also, the first step we're going to have to take for this formula is the percentages must be in decimals for this equation to work. If you do not take the 58.4 and the 38.0% and make them a decimal, this problem will not work. To get them to decimals, you're going to divide the 58.4 by 100 and the 38.0 by 100, which gives you 0.584 and 0.38. So now comes the fun part, plugging these numbers in the appropriate places. So if you get in a hurry, it's pretty easy to make a mistake. So right now I'm going to use my highlighter. So first we are going to do the in. So 0.584, I'm just going to highlight right now. It's going to go in the in spot. So in minus out, and then in for in minus, and then in times out. Like I said, it seems pretty straightforward, but if you get in a hurry, you can get these mixed up pretty quick. The 0.38 goes in the out spot. So in minus out, and then on the bottom formula, the in times out. So that's where we're going to plug these in. In the next slide, I'll have them plugged in. So whenever you take your exam, you get a dumb calculator. You don't get a scientific calculator. You don't get the cell phone. So you're going to have to solve each part of these separately. So the volatile solids reduction percent is equal to 0.584 minus 0.38 divided by 0.584 minus 0.584 times 0.38. So we're going to solve for the top. That's 0.204, which will be divided by 0.584 minus 0.584 times 0.38. So we'll go ahead and solve for the bracket on the bottom. That is 0.22192. So now you're going to subtract that from 0.584. So 0.584 minus 0.22192. You get 0.36208. So now we're going to do our division. So 0.204 divided by 0.36208. And you get 0.563. I'm going to multiply that by 100%. And your final answer is 56.3%. So it's not super difficult. It's just making sure that you get the in the in spot and the out in the out spot, which I messed up several times while making this PowerPoint. The contents of influent sludge is 8% solids and 71% volatile. The effluent sludge is 42% volatile. What is the percent volatile solid reduction? pull out your known and your unknowns for this question. So what you know is the influent volatile percent is 71%, the influent sludge is 8%, and the effluent volatile is 42%. We are looking for the volatile reduction percent. So they've given you more information than you need. You don't need the 8%, you just need the influent volatile percent of 71 and the effluent volatile percent of 42%. And again, the formula for volatile solids reduction percent is in minus out divided by in minus in times out times 100. The first step in these problems again is to convert your percentages into decimals, otherwise the math will not work out. So we're going to do the 71 divided by 100 and the 42% divided by 100. And you get 0.71 and 0.42. Now we're going to plug these in. And again, I will use my wonderful highlighting skills. So the 0.71 is the in. So 0.71 is going to go on all the in spots, which I've highlighted. And the out, 0.42, is going to go in the out spots. So like I said, do not get in a hurry when doing this math problem, which is a relatively easy math problem, unless you put the in the out spot and the out in the in spot, and then you'll get the wrong answer. So here's the numbers plugged into the formula. So it's volatile solids reduction percent is equal to the in of 0.71 minus the out of 0.42 divided by the in of 0.71 minus the in of 0.71 times the out of 0.42 times 100. So we're going to do the top brackets first. I'm going to solve for that. So 0.71 minus 0.42. The answer is 0.29. Next, we're going to do the 0.71 times the 0.42 in the bottom brackets. The answer for that is 0.2982. Now we're going to do our subtraction. So 0.71 minus 0.2982. And you get 0.4118. So now we're going to solve for the division. So 0.29 divided by 0.4118. And I get 0.70. We're going to multiply that by the 100%. And the answer is the volatile solids reduction of 70%. Alright, so the waste activated sludge into an aerobic digester is 75% volatile, and the digested sludge to the belt filter press is 69% volatile. What is the percent volatile solids reduction? So we pulled the knowns and the unknowns out. So what you know is that your influent, so into the digester, is 75%, and the effluent leaving it was 69%, and we are looking for the volatile reduction percent. So the volatile solids reduction percent is equal to in minus out divided by in minus in times out times 100. So we're going to convert the percentages into decimals. 75 divided by 100 and 69% divided by 100. You get 0.75 and 0.69. We plug these into the formula. 0.75 minus 0.69 divided by 0.75 minus 0.75 times 0.69. We can solve for the top. 0.06. We're going to solve for the bracket on the bottom. 0.75 times 0.69. You get 0.5175. You subtract that from 0.75. So you get 0.2325. You're going to divide that into the 0.06. So 0.06 divided by 0.2325. And you get 0.2580. We're going to multiply that by 100 to get to the percent. You get 25.80%. Calculate the percent volatile solids reduction by weight if the digester influent sludge has a VS content of 65% and the digester effluent sludge has a VS content of 51%. So pull your knowns and your unknowns out of your word question. An influent of 65% and an effluent of 51%. So in of 65, out of 51. We're going to have to convert those to decimals. So you divide the 65% by 100 and the 51% by 100. You get 0.65 and 0.51. We're going to plug those in to our volatile solids reduction formula. So the in of 0.65 minus the out of 0.51 divided by the in of 0.65 minus the in of 0.65 times 0.51. So I'm going to solve for the top bracketed problem first. So 0.65 minus 0.51, you get 0.14. I'm going to solve for the bottom bracket of 0.65 times 0.51, and you get 0.3315. Subtract that from the 0.65, so 0.65 minus 0.3315, and you get 0.3185. So next we're going to divide the 0.14 by the 0.3185. You get 0.439. We're going to multiply that by 100%, and we rounded it and got the answer of 44%. If the digester influent sludge has a volatile solids content of 61% and the digester effluent sludge has a VS content of 48.5%, by weight, calculate the percent VS reduction. So we pull our known or unknowns from our word question. So what we know is the influent of 61% and the effluent of 48.5%. And what we're looking for is the volatile reduction solid percentage. You still have to convert your 61% and your 48.5% into decimals, so divide each of them by 100. That's going to give you 0.61 and 0.485. So we're going to plug those into our formula. So the in of 0.61 minus the out of 0.485 divided by the in of 0.61 minus the in of 0.61 times the out of 0.485. So again, seeing we're using dumb calculators, we're going to have to solve for each portion of this separately. So 0.61 minus 0.485, and you get 0.125. Next, we're going to do the bottom bracket, 0.61 times 0.485, and you get 0.29585. We're going to do our subtraction, so 0.61 minus 0.29585, and you get 0.31415. We're going to do our division, so 0.125 divided by 0.31415. That's 0.40. We're going to multiply that by 100%, and your final answer is 40%. So that was 5 questions worked through on volatile solids reduction math. It's not too bad. Like I said, the hard part's just going slow and making sure you get the in where the in goes and the out where the out goes. And when you take your exam, you don't get a smart calculator. You get a dumb calculator, not a scientific one. You don't get to use your cell phone, so you have to solve each part separately to make sure you get the right answer. And it takes multiple steps, and you just have to be patient with it. Like I said, I messed up several times when I made the PowerPoint, but hopefully watching this will help you study and learn. Thanks.